Hello and welcome to some pedigree information with Miss Shimel. This is a pedigree that you can see in front of you. A pedigree is basically a family tree. You can see that two individuals are married and you can see the number of children, offspring that they have. In regard to the circles, these are females. In regard to squares, these are males. If they are joined together by a straight line like this, that's considered a marriage line. It doesn't necessarily mean they're married, but they are breeding and having offspring. Therefore, this line that you see down below that kind of looks like a bracket, this is called a sibling line. In this case, there are 1, 2, 3 siblings. In the case of this family, again, we have a mother here, we have a father here, and they have 3 children. This one is a daughter, this one was the first son, this one is the third son. So we have a son, daughter, son. The reason that these ones are shaded is because they have a specific trait that we're going to focus on in this pedigree. To help us recognize which generation is which and which individual is which, we can use some numbers. We first use Roman numerals to signify the generations. If you notice, there's generation 1 up top. There's a second generation, these would be the offspring or the children, and then down here we have the third generation, which would become the grandchildren. This becomes grandma, this becomes grandfather, and then these would be the grandchildren way down here. After we number the generations using Roman numerals, we just use regular numbers to label the people from left to right as we would read here in the United States. So generation number 1 has individual number 1 married to individual number 2. We have the female together with the male. They have 3 children for generation number 2. These parents have these 3 offspring. So there is a boy, a girl, and a boy for their generation. For generation 2, the first individual marries the first son from this couple. Does that make sense to you? What can you tell me about individual number 1, number 2? He is an unshaded male that's married. What can you tell me about individual number 2, number 5? Number 2, number 5 is a female who is married to an unshaded male. She has whatever trait is in question. What can you tell me about individual number 3, number 2? What gender is this person? Do they have the trait or not? This is individual number 3, number 2. She is a female and she is shaded, so she has whatever trait we're talking about. A lot of times you can take a look at a pedigree to help you interpret the pattern of genetic inheritance. For example, are there more people that have the trait or do not? And how would it be possible for individuals number 1 and 2 to have offspring that are shaded, but they themselves are not? In this case, we can assume that the top 2 parents, these are going to be heterozygous for a trait. We really can see from up above, where it says number 20, fill out the genotypes on the pedigree chart. If we're looking at short hair being dominant and long hair being recessive, we're going to use the capital H for short hair, and we're going to use HH, the little lowercase letters, to signify long hair. Those people that are not shaded must have at least one dominant gene. Those people that are shaded on the chart, automatically we know they are homozygous recessive. For example, this female right here, she has to get 2 little H's to get her to be shaded in. These people up here also have to be shaded in. They have the long hair trait, which is recessive in this case. Anybody who is not shaded automatically gets at least one of the dominant, which is short hair in this case. But we don't know if they are homozygous or heterozygous unless there's more information. For example, for generation number 1, individuals numbers 1 and 2 must both be heterozygous because they have offspring, children here and here, that end up with the recessive trait. They must pass on their recessive trait from the top down to the next generation. For this pedigree, again, we know that the long-haired offspring are automatically recessive, so they must be little h, little h. I'm going to fill that in here. Can you see the homozygous recessive people that are now labeled? Next up, we know that the parents up at the top must be both heterozygous for their trait because they have children that end up being homozygous recessive. We don't know for sure about this patient yet. So if we're looking at individual number 4 right here, can you figure out their genotype? If we are looking at generation number 2, person number 4, this male, he's married to a female who is, she's homozygous recessive. She can only pass on her little h to her offspring. So how would this person end up with a big H, little h? They had to have gotten it from this person. How do we know that person generation number 2, number 4, has the big H? Because they're not shaded. If we are still looking at person number 4, we know that they have at least one big H because they are not shaded. We know that this mother right here has to be little h because she is shaded in. If these two parents have offspring, they would end up with maybe one daughter who is dominant, like this, so she is big H, little h, because mom gave her the little h, that's all the more she could get. But the father had to have at least one big H. But what is his other letter? What else goes here? Is there enough evidence to help you with this? How is it possible for this father to end up with a little h child? Mother passed on the little h, but how could this child get another little h? It had to have come from the father. So this father must be big H, he's not shaded, but he must also have the recessive gene to have any offspring that end up getting the trait. Here's a better, different Punnett square to show what happens when individual from generation 2, number 4, and number 5, the female, get together. If generation number 2, individuals number 4 and 5 get together, their offspring end up being 50% for recessive and 50% for being dominant. This one must be homozygous recessive. This one must be heterozygous dominant because the mother, number 5, can only pass on the recessive genes. Do we know the genotype of generation 2, individual number 2? Of course we do. This must be little h because it's long-haired, which is recessive. Do we know the genotype of the mother here for generation 2, number 1? See if you can figure it out. We know that the individual, the male, that is short-haired right here gets their father's little h. We know that he gets his mother's big H. So this person must be big H, but do we have enough information to know the rest? Without more offspring, we really don't know. This one could be homozygous or heterozygous dominant. Individual for generation 2, number 1, can be homozygous or heterozygous dominant. We just don't know. In summary, we use Roman numerals to signify each of the generations. We use regular numbers going left to right to number our individuals. We show a marriage line between a female and a male and a female. We show offspring as brackets. We show the marriage line as a straight line. Children are produced from that marriage, the fusion of the egg with the sperm. It is possible to interpret the genetic distribution whenever we look at a pedigree. People that are shaded have a specific trait in question. Typically, if there are lots of people that have the trait and pass it on, have the trait and pass it on, that's probably a dominant trait. If you have parents like numbers 1 and 2 who don't have a trait but end up with offspring that do have this, then most likely it's a recessive trait. This is the key to number 20 from the Pedigree practice worksheet. All of the pedigree is filled in. The only one that might be in question is individual from generation 2, number 1. This person over here, we don't know if they're homozygous dominant or heterozygous for their trait. They do have short hair. They do breed with a male who has long hair, but their first child ends up being dominant just like the mother. So we don't know enough. I hope you know enough now about pedigree and pedigree analysis. Thanks for watching this pedigree analysis with Miss Shimel. Take care.